Dear students, in the previous video, we went through the topics of embedded system. So we had an introduction of what is meant by system, what is an embedded system, what are the basic functionalities, what is the purpose, applications, advantages, all these things we discussed in the previous video. Now in this video, we are going to start a typical embedded system and we are going to see in detail what are the quality as well as the characteristics of an embedded system. So this is a typical block of an embedded system. So as you all know, an embedded system is a special purpose computer system which is designed to perform a specific task or a set of based on a set of rules. So that means the embedded system is supposed to work for a uh, defined task, dedicated task. So it is embedded as a part of large device which interacts with the real world environment through certain inputs and output devices such as sensors and actuators. And the diagram shows below represents the basic architecture of the block of a typical embedded system, which consists of a system core. A memory element is there in which the embedded firmware is embedded into this memory element. And this memory element is connected to the system core, and the system core is having certain controllers such as the processors such as the microprocessors, microcontrollers, FPGA, ASIC or DSP or SoC. It means it includes both the general purpose as well as the application specific type of devices. So these any of this will be embedded into this system core. So the system core can communicate to the real world through input ports such as sensors, and it can the response of the system core can be sent to the real world environment through certain output ports, which we call it as the actuators. Other than that, there are other supporting integrated circuits and subsystems. Along with that, there are certain communication interfaces are also there, which we'll discuss in detail. So coming to the system code, which is a main part of the embedded system, we can say it as the heart of the embedded system. Often it can contain a microcontroller, a microprocessor, digital signal processor, FPGA, ASIC or SoC, and it executes the embedded firmware and coordinates all the operations. Also, it handles the input processing, decision making, and output control. So, coming to the memory part, memory is used to store embedded firmware, program, and temporary data. So, it includes two types of memory. First one is a program memory ROM, where the embedded firmware or the embedded program is being stored. And the second one is the data memory, which is a RAM, which stores the runtime data and the variables. As we all know, ROM is a non-volatile memory. That means that data will be retained even when the power is off. And RAM, it is a volatile memory and the data will be lost once uh, the power is off. And this firmware is often written into the memory during the system design and tested before the deployment phase. And the figure shows the subcategories of different types of memory devices, that is PROM, MROM, EPROM, E square PROM, flash memory, then comes the VRAM. Similarly, the data memory also divided into SRAM and DRAM, where SRAM and DRAM are the static and dynamic RAM. Okay, and the static RAM, the function based mainly based on the transistors, and the data is stored here in transistors only, whereas in dynamic RAM, here the data is stored in using capacitors. Then comes the I/O ports. So coming to the first one, input port. So these are the interfaces which receive the data or signals from the real world through sensors. So what are the various sensors we use here? It can be any of the sensors such as temperature sensors, IR or pressure sensors, whatever it is, which converts a physical condition into electrical signals and send them to the signal code for processing. So considering this output ports, basically the output ports we used are actuators. So these output ports are the interface that sends signals from the system to the real world to control actuators. Examples includes motors, buses, LED speaker, relays, etc. And the system code processes signals that it got from the input devices and send the signals to the actuators based on the logic which is defined in the embedded firmware. Then what are the various communication interface which this particular a typical embedded system has? So it consists of certain UART, which are the serial interface, I2C, which is inter-integrated circuits. It's a two-wire bidirectional bus for short distance communication on a PCB, and wireless devices like wireless concepts like Bluetooth, Wi-Fi, Zigbee also, which enables data exchange, remote monitoring, and firmware updates. In addition to this, there are other supporting ICs and subsystems, which includes the power supply circuits, ADC, DAC, and voltage regulators, which assist the main system in functionality, reliably and efficiently. Then comes the embedded framework. The software code which is written in the embedded application and it is stored in the ROM memory and executed by the processor. Also, it performs operations such as reading sensor data, processing it, and control the output. Coming to the real world interaction, the embedded system takes input from the real world, processes the data, and produces the output that affects the real world through actuators. Example, in the case of a temperature control system, a sensor reads the room temperature and if it is exceeding the threshold value, the system turns on a fan using a relay. So that is the basic working of a temperature control system. So in short, we can say like a typical embedded system is a tightly integrated combination of hardware as well as software, which is designed for a dedicated function. It includes a processor, memory, I/O interface, communication components, and supporting hardwares. Also, it interacts continuously with the real world through sensors and actuators, making it ideal for applications such as automation, consumer electronics, automobile systems, healthcare devices, and more. So what are the various characteristics of an embedded system? The various characteristics of embedded system includes application and domain specific, reactive and real time. It operates in harsh environments. We have already discussed the concepts in detail, so I'm not going in detail regarding this. It's a distributed system. That's embedded system can be a part of the larger system and the work together. It is small in size and weight and it is having power concerns also like it is battery operated and it is having majority of low power components and power regulators and different saving modes are also there. What are the quality attributes of an embedded system? So quality attributes are non-functional requirements which are essential for the design and success of embedded system, and they can be basically classified into operational quality attributes and non-operational quality attributes. So what is meant by operational quality attributes? What are the various operational quality attributes? Operational quality attributes are those attributes which are relevant while the system is running in online mode, like it is when the particular equipment is working. So whenever system is working, whenever a system works, the following parameters came into effect, like response, throughput, reliability, maintainability, etc. Okay, so response means what is the response of the system when we give an input, right? So now comes the reliability. What means how much we can reliable on a particular system. Like it indicates a system's resistance to failure, which can be measured using mean time between failures and mean time to failure. What is the time between the failures and how much time it takes to get fail for a particular system. And then comes maintainability. It refers to the ease of performing maintenance. Basically, there are two types of maintenance. One is scheduled maintenance, which will be done at particular time instance. That is known as preventive maintenance in order to prevent the system from being damaged. Next is unexpected failure will arise. So because of that, we need to do an extra maintenance. So that is unexpected maintenance. That is a corrective maintenance mechanism. Then comes security. In the case of security, there are basically three parameters: confidentiality, integrity, and availability. So, which prevents the unauthorized data access and also unauthorized data modifications and uh, ensures only authorized users to access the data. That is availability. And coming to the safety, so it protects users from environment from harm due to failures and also covers sudden dangers. Now, what are the non-operational quality attributes? These are the quality attributes that are relevant before deployment or during deployment or development. Deployment means development time. So, what are those? Testability and debugability, uh, evolvability, portability. So, what is meant by testability? Means ease with which system can be tested or debugged. How easily we can debug a particular system. Evolvability. It refers to the system's ability to get adapted, flexibility, portability. That is how we can easily transform this. How it is it portable? Is it like can be ported to different platforms, different OS? These are the things. Time to prototype and market. So time from concept to working product. So how much time it took? Then per unit cost and revenue that include during the entire product life cycle. So the cost analysis is vital for market success. So these are the major quality attributes, operational as well as non-operational attributes. So with this, we are winding today's session. So will all of you please go through this video. Thank you.